You've skipped 13, you're working on 15, correct?
Yep.
Deal.
Listen.
Yes.
So on the AP test as well as just on tests and such, what is how many decimals do we need to write down?
Oh, thank you, sir. I had that in my notes of things to start the period off with. Guys, 3 past the decimal point or it is wrong. I just graded a bunch of, not a bunch of, I graded one problem of the week yesterday. And about half of you decided to start rounding to the nearest tenth or something random. You picked your own rounding rules. In this class, in calculus, if it's not 3 past the decimal point and you round, you're guaranteed to be wrong. There's no option. It's a wrong answer. So you have to go 3 past the decimal point on everything you ever do. Does that answer your question, sir? No.
I can't say this without saying what I got for 15. So do you want me to do
Yeah, you can say what you got for 15. Let me do 15. Let's do 15. I'll do 15. Let's see here. I got the radius of a circle is increasing at a rate of, so I've got a circle of some sort. Start with a circle. And circles have radiuses. And it's saying that my radius increases at a rate, so I want to know the rate at which my area changes. So the ADT, given that the RDT equals 3. And my radius at the first case, at least, is going to be 6 centimeters for future reference. All right, here's how we do this problem. Let's actually, go ahead, sir. Sutton, go ahead and do this problem.
So the area for the equation of the area of a circle.
What's the area of a circle equation?
Pi r squared.
Pi r squared. Love it. That's one you have to have memorized, everybody. If not, if you don't have it memorized now, write it down on a piece of paper of things you have to memorize. That's it. They expect you to find the area of a circle formula. All right, sir, what do I do to it?
Isn't it called interval derivative or intermittent? What have we been doing this chapter?
This is called a related rate. It's really close to implicit differentiation, which we started the chapter with.
That's what I meant.
Right.
I was just like, I'll take the derivative on both sides.
Take the derivative on both sides with respect to what in this case?
Time.
Time. Okay, so let's do it.
So or dA over dt equals pi 2r dr over dt.
I love it. We know we have the right formula. If I plug things in, I get an answer. So the ADT is what I'm looking for. I got pi. I got 2. What's r?
6.
6 in this case. The RDT?
3.
3. So you should be writing down 36 pi centimeters. Why are you writing this at all?
Oh.
Now, if it was in the calculator part of your test, you could get away with the following. 36 times pi you can write it as 113.097 centimeters.
Okay. So that's why I asked what I asked before. I was confused because I wrote that as 113.0. You know?
That's
But I
wrong.
have to do all three of them.
You always 3 past. There's the decimal point. You always go 3 past. It doesn't matter what it is. They're talking about how many watermelons are in the field. You go 3 past the decimal point, even if it makes no sense at all.
Okay.
You don't judge. You just do it. They have frankly, it's one of the best rules they have in this calculus test is they tell you exactly where to stop rounding, which is nice, right? That's at least a plus. But it's always 3 past the decimal point, no matter what you're talking about, no matter why. Now, once in a blue moon, they'll say round to the nearest penguin or something. Follow their instructions, right? But and by the way, if they say round to the nearest penguin and you go 3 past the decimal point, it's still right. They'll be fine with that. Okay? So my advice is just get grilled in your head. I'm going 3 past the decimal point no matter what. Okay?
Okay.
That makes sense? All right. You should be able to do part B really easily. Then you're going to run into 17, which is horrific.
Thank you.
You know what? We're going to skip A, although you should look at it for a moment. I'm not going to ask you to prove that. That's going to require some trig. Let's not do that, shall we? Let's instead take a look at B. Hey, you know what? No. Do you guys want to try A? Who's my bold spirits? Who's the person who'd be next on there? Pete Scott! Should we try A or not?
A for 17?
Yeah.
Let me read it real quick.
All right.
Yeah, I don't know what it's asking.
It's asking you to derive like it's in a proof. That the triangle's area must be 1/2 x squared sine theta.
I mean, I don't know how to do that.
Okay.
But like,
all right.
you can teach me, I guess.
We'll leave it on the table. You should definitely read that though, but we're not going to do A. We'll start with B. We'll start with B. I would recommend drawing a picture, by the way, as well. Oh, come on. I can't look at your papers. All right. I will pick for you. Let's see here. Moving from left to right. Oh, it's Brianna Solis' turn. Miss Solis. Miss Solis? Uh-oh. Sandwich time. Miss Spaniel. Should be.
Yeah.
Good. Miss Spaniel, thank you. All right, let's do this problem together. So let's do a step. Can you do this? Do you think you did well on this problem, or are you struggling? Because I think most people will be semi-struggling on this one.
I struggled. I got stuck.
Okay, fair enough. All right. So let's start off with what we're supposed to do. One, write down what we know. Based on the question B, what do I know?
The rate of d theta over dt is 1/2.
Okay. I want you to start saying the change in theta with respect to time. Right?
Okay.
How much the angle is changing with respect to time. We want to start making that part of our language. So it makes a little more sense. Okay. What else do I know?
We're trying to find the rate when theta is pi of 6 and pi over 3.
I'm just going to do one right now. We can let's figure out the other one a second time, right? Anything else I know?
No.
All right. Oh, I wrote X's up there. Their sides are actually length S. Is that okay with you?
Yeah.
Can I make those X's instead?
Yeah.
Oh, let's just make them X's instead because S is just kind of an abysmal number. Okay, so I need to know something that relates X and theta. What do you got for me?
You just do like the area
Right. The whole purpose of that intro was to make you, hey, here's a formula for you to use, right? It's not a formula you'd commonly run across. So always be suspicious of formulas that they give you out of the blue. All right, what do I do?
Plug it in.
Plug what in?
You plug the data in.
No, is data changing?
Resonate.
Yes.
What it gave us. Oh, wait, did you purposely change it to cosine from sine theta?
Oh, I did not purposely change it. In fact, it is definitely not cosine. Thank you. Whoop. Thank you. I can't plug. Now, is theta changing, this manual?
No. Wait, yes.
Yes, since it's changing, I can't just plug it in. I first got to take the derivative of both sides.
Okay.
Okay, because one depends on the other, so I got to get the other one out of there too. So how do I take the derivative of both sides? With respect to what?
Wait, say that again?
How do I take the derivative of both sides and with respect to what letter?
X.
Uh-uh.
Data. No?
I want to know how fast it's changing. That's a time question, right?
Yeah.
So I'm going to take the derivative of both sides with respect to times, okay?
Okay.
All right, let's do it.
So it's 1/4.
Over here. Here's the A.
The change in data respect to time.
We're,
Or the data over dt.
wait a second. What are we doing over here? We're supposed to take derivatives with respect to time on both sides, correct?
Yeah.
So what's the derivative of A with respect to time?
D of A over D of T.
Changing the area with respect to time equals, now I'm going to do this mess. It's two things multiplied together, right?
Yeah.
What rule applies?
The product rule.
Product rule, let's do it.
Okay, 1/2 x squared times cosine of theta plus
I need something right here. Because I took respect to time, not theta.
the d theta over dt.
Okay? Plus?
1/4 x.
1/4. If I take the derivative of that, I don't get 1/4.
And not
Throw the 2 out in front.
1, sorry,
So you 1, yeah. So just be x
sine theta.
times cosine theta, right? This is not a t, is it?
Isn't it times sine theta?
Oh.
Yeah.
Wait, what did I do here? Which one? This one should have been sine theta. What did I? Whoa, no. So yes, no, got it. I'm distracted by something else. Hold on. Yes, thank you, perfect for that. How about the x? That's not a t, is it?
No.
So I have to take. What's different for the second part? Yeah, only the pi over 6 is going to change, right? So that's going to put us the same.